Your mitochondria are often called the powerhouses of your cells, but that description really undersells what's happening here. These tiny organelles are central to understanding why we age and what we might do about it. The mitochondrial theory of aging proposes that accumulated damage to mitochondria drives the aging process itself, and the evidence supporting this is substantial. Here's the concerning part. As you age, your mitochondrial DNA accumulates mutations at a much faster rate than your nuclear DNA. Why? Because mitochondria are where oxygen is processed, and this creates reactive oxygen species as byproducts. These free radicals damage the very mitochondrial DNA that produces the proteins needed for energy production. It's a vicious cycle. Damaged mitochondria produce more free radicals, which cause more damage, leading to declining ATP synthesis. Your cells literally produce less energy as you age. But let's move to what you can actually do about this, because there are legitimate interventions here. Certain nutritional compounds have shown real promise in supporting mitochondrial health. Pyrroloquinoline quinone, known as PQQ, appears to promote mitochondrial biogenesis, meaning the creation of new mitochondria. Coenzyme Q10 is crucial for the electron transport chain where ATP is produced. Alpha-lipoic acid functions as a powerful antioxidant specifically within mitochondria. These aren't magic pills, but the research on their mechanisms is solid. Exercise, particularly specific types, is remarkably effective at promoting mitochondrial health. Zone 2 cardio, that moderate intensity exercise where you can still hold a conversation, has been shown to increase mitochondrial density and improve their function. Resistance training triggers different pathways that also support mitochondrial biogenesis. The combination of both types appears optimal. Cold exposure therapy is gaining serious research attention. When you expose your body to cold, it activates pathways that increase mitochondrial biogenesis, particularly in brown adipose tissue. We're talking about deliberate cold exposure, cold showers, or ice baths, not just turning down your thermostat. The hormetic stress from cold triggers adaptive responses that strengthen mitochondrial function. Intermittent fasting deserves serious consideration in this context. When you fast, you activate a process called mitophagy, where your cells selectively break down damaged mitochondria. This is cellular quality control. You're essentially allowing your body to clear out dysfunctional mitochondria and promote the generation of new, healthy ones. The timing matters, though. Fasting periods of 16 to 18 hours appear optimal for triggering mitophagy without causing excessive stress. Here's a critical warning. Supplementation timing and dosing matter significantly. Taking CoQ10 with fats improves absorption. PQQ dosing in studies typically ranges from 10 to 20 milligrams daily. Alpha-lipoic acid should be taken on an empty stomach for best absorption. These details aren't trivial. They affect whether these interventions actually work. The integration is what matters most. Combining nutritional support with exercise protocols, cold exposure, and strategic fasting creates synergistic effects on mitochondrial health. You're not just addressing one aspect of mitochondrial dysfunction. You're supporting the entire system. That's when you see meaningful improvements in energy production, reduced oxidative stress, and potentially slower aging at the cellular level.